So section 3.1, we already explained the tangent line problem. So if you have, we need to find the tangent line problem. So remember, this is the distance between this point. I'm going to choose any point on the curve because my goal is to find the tangent line for this curve. And then we're going to keep going. Here is delta x, which is the distance between this point and this point. Here is the coordinate for this point, which is at point C. Here is f to the c, which is, that's mean here is x, y. And the same thing here, the second point is going to be, this is x and here is y. Because this point plus delta x is going to be here. And the y is going to be f to the c plus delta x. And here is going to be delta y, which is the difference between f to the c plus delta x and f to the c. And we said that the first thing, we're going to find the secant line is going to be here. And then we're going to choose another point here, another point here, another point here. And we're going to keep going until the secant line attach the tangent line, which is going to be here. So in this case, the slope of the tangent line is going to be the limit when delta x approaches the 0. That's mean we're going to keep going until delta x, because c minus c is going to be 0. That means delta x approach to the 0. That means here's the first secant line, and they're going to keep going like this until we reach this secant line is going to be exactly like the tangent line. Here is our tangent line, and this one is the secant line. Delta y over delta x, delta y, which is the same thing here, is going to be f to the c plus delta x minus f to the c over delta x. So in this case, we're using the limit because we need to approach to the x equals c. So at this point, x equals c, here is going to be the formula to find the slope of the tangent line. In general, at any point, x is any point. So at any point, the slope of the tangent line is going to be the limit when delta x approaches to the 0, f x plus delta x minus f to the x over delta x. So here's the rule we're going to use. It's the same rule. To find the slope, it's the derivative of the function. The derivative of the function, which is the slope. That's how you're going to find the symbol of the derivative. F prime, that means this is the slope. F prime of x, which is mean the slope of the tangent line. Then dy over dx, y prime. D over dx to the f of x, that means this is the slope. D sub x to the x, that means this is the slope. So now, we're not going to say find the slope anymore. We're just going to say find the derivative. So you have to keep in your mind the derivative, it's mean the slope, which is exactly the same formula. F prime to the x is going to be the limit. Delta x approach to the 0. Fx plus delta x minus f of x over delta x. So that's mean every time when I'm asking you find the slope or find the derivative, it's mean the same thing, the slope. The slope, it's mean the derivative when the tangent line approach to the secant line. When our secant line approach to the tangent line, okay? So it's the slope. We will see that with the first example, the second example, how to use the formula. And always they're gonna ask you, find that, because next section, we're gonna use the same thing, but we're gonna find the first rule, then we're gonna find the second rule. So we're going to use the rule. But if they're telling you find the derivative by using the limit process, you have to use this rule. Find the derivative by using the limit rule. That means you have to use this definition. Okay? you have any questions, do not send it in the chat, and you mute yourself and ask me. So the first example, they ask you to find the slope of the tangent line, and here is our function at this point. So let's see. You can use the division to find the slope, it's fine. But if you look to this example, it's a linear equations. It's a linear. Why it's a linear? Can you that? What was the difference between linear and a quadratic? Linear, the exponent is 1. So if you look to the exponents here is 1. That's why it's a linear equations. So if it's a linear equations, I need to find the slope. This equation is similar to y equal mx plus b. Which is the y-intercept form, mx plus b. This is the linear equations y-intercept form. This is called y-intercept form. So this one, similar to this one. F of x is the same thing, mean y. So that means here's our slope. So the slope for this line is going to be 4/7. And the intercept, which is the point 0, and here is b, so it's going to be 0 and 8. So here is the y-intercept point, and here is our slope. So this is for the first example. So always when you have linear equations, to find the slope, I'm just going to use this formula. I don't have to use the division to find the slope of the limit, because it's a linear, it's just a straight line. That means the slope of the straight line is going to be exactly tangent line on the secant line, exactly the same line, because it's a line. It's not a curve like the tangent line problem. But if you look to the second example, find the slope of the tangent line at this point, and look to the equations here. It's a 3x squared minus 6. That the difference between the second example and the first one, this is linear, but the exponent here is 1. This is quadratic. The exponent here is 2. I can't use the same formula, because this is the formula only for the linear. So in this case, I have to use the definition, which is to find the slope, you have to use the limit. So next step, this is f of x. That means f to the x plus delta x is going to be. That's the difference. That is going to be the issue here. You have to be careful. F to the x plus delta x. So f to the x, we have it, the x here. Okay. Now we have f to the x plus delta x. That's me. I'm going to plug in, and instead of this x, here is the 3. I'm going to plug in x plus delta x. And here is the square. So that's the important thing. Here's the x. I'm going to take out the x and put everything here with the parentheses. Square, here's the x squared. So here's the square. And keep going, minus 6. If you want to simplify it here, it's fine. If you want to, when you plug and simplify it, it's going to be fine. Both ways going to be right. So now I have to go back and use the slope. The slope says equal the limit when delta x approach to the 0, f to the x plus delta x, this is the rule, minus f of x divided by delta x. Now I'm going to plug in. This one is going to be here. F of x is going to be here, divided by delta x. So this one is going to be equal to the limit when delta x approach to the 0. F to the x plus delta x, yes, going to be 3 x plus delta x squared minus 6. Then I have minus f of x, which is here's f of x. So here is minus And f of x is going to be 3x squared minus 6. If you're not putting the parentheses, you're going to get something wrong here because you're going to distribute the negative sign on both these two terms. So be careful. Put the second part like here, always with parentheses. Any questions so far? Before moving to the next step? Next step, this one is going to be equal. Here's the limit. X, delta x approach to the 0. Now, what I have to do on this part here, x plus delta x squared, I have to distribute this one, FOIL it. Because this one is x plus delta x times x plus delta x. So I have to FOIL this one, x times x. So here's the 3, open parentheses, x times x is going to be x squared. X times delta x is going to be x delta x. So plus x delta x. Now delta x times x plus again x delta x. Delta x times delta x, so it's going to be plus delta x squared. See, I put parentheses here because I need to distribute the 3 on each term here. So that's why I put parentheses. Minus 6. Now I have to distribute the sign. Negative times 3x squared is going to be negative 3x squared. Negative times negative is going to be plus 6. Everything is over delta x. Next step, this one is going to be the limit when delta x approach to the 0. You want to distribute and combine the log terms, so it's going to be 3x squared plus 3x squared, so it's going to be 6x delta x. Because I can combine these together. Plus 3 delta x squared and minus 6 minus 3x squared plus 6. And everything divided by delta x. Now, next step we have to check. I can cancel this one with this one, with one positive, one negative, negative 6 with positive 6, and check what's the left here. 6x delta x plus 3 delta x squared over delta x. So that's the left. So, limit when delta x approach to the 0, 6x delta x plus 3 delta x squared divided by delta x. What's the next step?
Let's simplify again.
Yes.
So
I can simplify by what the GCF on the top, because that's my goal. GCF is, can I take 3x or 3 delta x? 3 delta x. But my goal is to cancel the delta. So I'm going to say, okay, I'm going to take 3 delta x. Let's do that. It's fine. So the limit when delta x approach to the 0, 3 delta x. So from this side is going to be 2x plus delta x. Everything divided by delta x. Next step, we're going to cancel delta x with delta x. So the left is going to be just the limit when delta x approach to the 0, 3 and 2x here. 3 and here 2x plus delta x. don't have to write down anything here. So let's check here. Now we're going to plug in. When delta x approach to the zero, that means this side is going to be zero. So it's going to be 3 times 2x. That means it's going to be 3 times 2x plus 0. And then the result is going to be 6x. So the slope for this function is going to be 6x. Okay, so that's by using the limit process.
Can you move the camera? You're blocking the work a lot of the time.
Move it to the left or the right?
To the right.
Now, that's good.
Yes, sir.
So for this example, find the derivative of the function by using the limit of x equal -6. So check here that I put this example because it's a little bit confused. You're confused with this one. It's -6, there is no x. It's just a constant function. So to find the derivative, we don't want to use the limit. We have to use the limit process. And we will see how much is going to be the derivative for this example. So the first thing I'm going to say, here's f of the x, f to the x plus delta x is going to be -6. There is no x value here, so I can plug in instead of the x value, x plus delta x. That's mean f to the x plus delta x is going to be the same number, just -6. So now I'm going to find the slope. The slope is going to be the limit. I'm not going to type the slope anymore because now it's the derivative. So we're going to say f prime to the x, which is being the same thing, the slope, is going to be the limit when delta x approach to the 0, f to the x plus delta x minus f to the x and divide by delta x. Now let's plug in everything here. Is going to be the limit when delta x approach to the 0, f to the x plus delta x is -6 minus f of the x is -6 for delta x. Then is going to be the limit when delta x approach to the 0, -6 plus 6, because you're going to distribute the negative sign. So it's going to be 0 over delta x. That's mean is going to be 0. So the slope for any constant is going to be 0. Next example. Let's see, this is just x squared here. Start again. X squared. Half of x equal x squared plus x minus 2. So now we need to find the derivative for this function. We'll do the same process. So here is f of x. Now I need to find f. Let me type it here. F to the x plus delta x is going to be. That's me a plug in, and instead of each x, I'm gonna plug in x plus delta x. So I'm gonna plug in here x plus delta x square plus plug in here x plus delta x, and here is -2. Plug in, and instead of each x, you're gonna plug in x plus delta x. So now the derivative f prime to the x going to be the limit when delta x approach to 0, x plus delta x minus alpha fill x and divide by delta x. So let's plug in everything here. It's going to be equal. The limit when delta x approach to 0, fx plus delta x, which is everything. So it's going to be x plus delta x squared plus x plus delta x minus 2. Everything divided by delta x. We didn't finish. This is just this part minus alpha fill x, which is x squared plus x minus 2. And everything is divided by delta x. The important thing here, when you FOIL this one, is 2 parentheses, so be careful when you FOIL it. You can do exactly the same thing that we did in the previous example. You're gonna say x plus delta x and x plus delta x. You can do that on the side, then plug in everything here as a result. So it's going to be the limit when delta x approaches to 0, x will be x squared, x times delta x is going to be plus x delta x and delta x. So it's going to be again x delta x plus delta x squared. Combine the like terms, it'll give you x squared plus 2x delta x plus delta x squared. Just FOIL these 2 parentheses and be careful. This is delta x and here is x. If you want to use 2 colors, so you're not gonna get confused here. Now I'm gonna bring back everything here. This is only for the parentheses. So I'm gonna type here x squared plus 2x delta x plus delta x squared. This is only for the parentheses. Keep going. Distribute the sign. So this one is going to be x plus delta x minus 2. Now we have to keep going on this side. Distribute the negative sign. So there is minus x squared minus x plus 2. And everything is divided by delta x. Next step, we're just going to cancel like terms. If you have like terms with different sign, I have to cancel it. So I have x squared. Here is negative x squared. I have positive x, and here is negative x. Negative 2, positive 2. See, everything here is cancelled with the left. The left, this term, this one, and this one. So it's going to be the limit. When delta x approaches 0, the left is 2x delta x plus delta x squared plus delta x. Everything divided by delta x. And what's the next step?
Simplify.
Yes, so that's what we're gonna do. Limit when delta x approaches 0. You see delta x here, delta x, delta x. I'm gonna take delta x as a common. Delta x, so the left is going to be 2x plus delta x here because we have square plus 1. And everything divided by delta x. Cancel delta x with delta x. So it's going to be limit. And delta x approaches 0. 2x plus delta x plus 1. Now, when the delta x going to the 0, that's mean this one is going to be 0. So the result is going to be 2x plus 1. So here is the derivative for the function, and on the same time, it's the slope for this function. And if you look, this fraction is a quadratic. So the slope for this one is going to be 2x plus 1.
Do we leave it like that, or do we need to solve for x? Like,
No, you don't have to solve it for x.
Oh.
Because your goal is to find the derivative. So for this fraction, the derivative is going to be this one. Okay, you don't have to solve it for x. That's it. So f of x now, we need to find the derivative. If we have a fraction, 2 over x minus 7. Let's check how we're gonna solve this one. So the same thing, f of x plus delta x going to be here, f of x plus delta x. Again, you're just going to plug in x plus delta x instead of each x. So it's going to be 2 over x plus delta x minus 7. That's it. Plug in x plus delta x in each. You can put parentheses. Then the next step is going to be without parentheses, going to be the same thing because you can't combine like terms and there is no sign here to distribute it. So just keep it like this. The next step, we're just going to take the limit. The derivative, which is f of prime to the x, is going to be the limit when delta x approach to the 0, f of x plus delta x minus f to the x, and everything divided by delta x. This is just the next step we need to plug in. So the prime to the x is going to be, here's the limit. F of x plus delta x is going to be 2 over x plus delta x minus 7 minus f of x, which is 2 over x minus 7, and everything divided by delta x. Now, here's the problem thing. How are we gonna solve this one? We have fractions on the top, and we need to combine these two fractions. And I have denominator here. So that's why I have to be careful with this example. If you have a fraction. So here's the thing. I'm gonna do something here on the side. If you want to combine two fractions, for example, 2 over 3, if you want to combine with 4 over 9. And check here, we have another number here. This is exactly like what we have here. Two fractions. We need to combine these two fractions and divide by delta x. So what I'm going to do here, I need to get the same denominator. So I can say that because there is no x, I'm going to multiply this one by 3 and this one by 3. But on the same time, you're doing a change on the top because this is also a fraction. So I have to multiply this one also by 3. Okay? Like when you multiply everything on the top, you have to multiply everything on the bottom because it's a fraction here and it's a fraction here. You have two fractions and also everything here is a fraction. So what I'm going to do here, I'm going to multiply everything here by the least common denominator, which is x plus delta x minus 7 and x minus 7. But on the same time, I'm going to multiply everything on the bottom by the same least common denominator. Because I can't multiply only the top. When you have a fraction, 4 over 6. Let's say 5 over 3. When you multiply anything on the top by 2, you have to multiply everything on the bottom by the same number. So the same thing here. If I multiply everything here on the top by a number, have to multiply everything on the bottom by the same number. So this one also multiply by x plus delta x minus 7 and x minus 7. So let's go to the next step. So it's going to be f prime to the x. Here is the limit. Delta x approach to the 0. I'm gonna write down everything here. So it's going to be 2 over x plus delta x minus 7 times everything here, which is x plus delta x minus 7 and x minus 7. Only for the first step. Minus, we have 2 over x minus 7 is going to be times x plus delta x minus 7 and x minus 7. And now everything is over delta x and x plus delta x minus 7 and x minus 7. Now we need to cancel, because our goal, when we multiply, this one is going to cancel with this one. And x minus 7 cancel with x minus 7. Now there is no fractions on the top, on the left. F of prime to the x is going to be the limit. Delta x approach to the 0. The left here is 2 and x minus 7. And the left here is minus 2 and x plus delta x minus 7. Everything divided by everything here. We can't cancel these. We have minus here. So we can't cancel this one with this one, this one with this one, because we have minus between the two terms. So next step, on the top, go ahead and distribute. Distribute here. Distribute here. So you're going to cancel the large terms. That means going to be f prime to the x is going to be equal. Limit when delta x approach to the 0. Going to be 2x minus 14 minus 2x minus 2 delta x plus 14. Because negative times negative is going to be positive. And everything divided by delta x, x plus delta x minus 7, and x minus 7. Cancel the like terms. This one with this one, negative 14 with positive 14. On the left is this negative 2 delta x over this part. Okay, f prime to the x is going to be the limit. And delta x approach to the 0. Negative 2x, negative 2 delta x over delta x, x plus delta x minus 7, and x minus 7. So now, I told you before, we have to make sure there is each term on the top contains delta x. That's what we have here. This term contains delta x. Cancel this one with this one. Now, when the limit of delta x approach to the 0, that means this term here is going to be, because you're going to plug in 0 on each delta x. We can cancel these two. So the limit when this delta x approach to the 0, that means this one is going to be 0. What's the left? The left is going to be negative 2 over x minus 7 and x minus 7. But we're going to plug in 0 here. So it's going to be x minus 7 and x minus 7, which is, you can type it as equal -2 over x minus 7 squared. That's it. That means the derivative for the quotient, which is fraction, is going to be -2 over x minus 7 squared. And again, in section 3.4 or 5, we're going to take the quotient rule, which is how to find the derivative without using all these processes. It's called quotient rule. Find the equation of the line that is tangent to the graph of f. And parallel, that means we need to find a line is tangent to this graph f. And parallel to the line, here's the line. So the first thing, we have a line and we have a graph. We need to find, there is no point. There's no point to find the equations of the line, and that's our goal. Our goal is to find the equations of the line, which is tangent to this graph. We have f of x, and parallel to this line. The first thing, my goal, I'm going to use the graph. I'm going to find the slope for the graph. Because I can find the slope for this line. The slope for this line, it's easy to find. I'm going to show you here on the side. Let's work to find the slope of other than x equal x squared. So we can't find the slope until we find the derivative. So the derivative for this one, add to the x plus delta x is going to be x plus delta x squared. I'm going to plug in the formula. That's mean the derivative, which is the slope, equal the limit when delta x approach to the 0, f to the x plus delta x minus f of x, and everything divided by delta x. Now let's plug in. That's mean f prime to the x is going to be the limit when delta x approach to the 0, fx plus delta x, which is here, squared, minus f of x, which is just x squared, and everything divided by delta x. Now again, we have to FOIL this part. So f prime to the x is going to be the limit of delta x approach to the 0. When I FOIL this one, is going to be x squared plus 2x delta x plus delta x squared. Here's minus x squared. And everything divided by delta x. So you see the steps to find the slope of the derivative is just a step. One step for this example. Now cancel the like terms because we have these that's been combined. Take the delta x as a common. So it's going to be f prime to the x. It's going to be equal the limit when delta x approach to the 0. Delta x as a common. So it's going to be 2x plus delta x divided by delta x. Cancel these. That's me. The slope of the derivative is going to be equal. Delta x approach to the 0, that's me. This one goes to the 0. Let's do another step. Is 2x. Delta x. So that's me. F prime to the x is going to be delta x approach to the 0. So this one is 0. So it's going to be only 2x. So for the graph, how much the slope? For the graph. For this graph, how much the slope? How much the slope of the graph?
2x.
2x, okay? You said 2x, so be careful. 2x. Now let's go to the line. For the line, we have 2x minus y plus 1 equals 0. Now I'm going to solve this equations for the y. Okay, that's mean I'm going to keep the y by itself on one side and move everything to the other side. So in this case, if I move the y to the other side, I'm going to add y. That's mean 2x plus 1 is going to be equal y. Is that right? Yes or no?
Yes.
Can I just switch everything? Can I write down y equal 2x plus 1?
Yes.
It's the same thing. Now, if you look to this one, it's exactly like the first equations with the first example. Because it's a linear, this is a linear, exponent is 1. This is similar to y equal mx plus b. Is that similar to this one? So how much the slope for the line?
2.
Be careful, it's just 2. So that's the difference. The slope for the graph is 2x. But the slope for the line, where is the slope? It's just the m, which is 2. That means the slope for the line is going to be only 2. The slope for the graph, whole thing here, 2x. Now, our goal for this example is to find the point. So we can write down the equations for the line. So I have now the slope for the graph. I have the slope for the line. You can finish? We have the slope for the line, just 2, and we have the slope for the graph. But they're telling you the graph is parallel to the line. That's mean when we have 2 parallel lines, they have equal slopes. When we have 2 parallel graph with the slope, the line here is parallel to this line. That's mean they have equal slopes. So the graph and the line, they are parallel to each other. That's mean 2x, because that's mean the slope, they have 2 equal slopes. The slope from the graph going to be equal the slope from the line. So 2x going to be equal to 2x is going to be equal to. Can I solve it for the x? That means x is going to be equal 1. So now that's my goal. X equal 1. Can I find the y? Yes. Our graph is f of x equal x squared. That means f to the 1 is going to be equal 1 squared equal 1. So how much the y? X is 1. How much the y? 1. F of 1 is the same thing, the y value when x equal. So that's mean in this case, y equal 1. So we have a point. XY, so we have 1, 1. So that's the point. Now I can write down the equations of the line. I have the slope and I have a point. So I'm going to say y minus y1 equal the slope x minus x1. So y minus y from the point equal to x minus 1. So it's going to be, just solve this one, y minus 1 equal 2x minus 2. Move the 1 to the other side, you're going to add 1. So y equal 2x minus 1. So that's the equations of the line. By the way, this is the slope for the tangent line. This is the slope of the tangent line, which is parallel to this one, which is from the graph. It's a tangent line. Consider f of x equals square root of x minus 1. Find the equations of the line of the tangent line to the graph of f of x at this point. So we have the graph, we need to find the equations of the tangent line. That means the first step, I have to find the slope. I have to find the slope. And that's the difference between this example and the previous one, because we have the point. I need to find the equations of the line, of the tangent line at this point. Tangent to this graph. So our goal is to find the slope. So let's start finding the slope, which is f of x we have equal square root of x minus 1. Then f to the x plus delta x equal, it's going to be square root of x plus delta x minus 1. I'm going to use the limit. That's mean f prime to the x, which is the slope, equal the limit of delta x approach to the 0, f to the x plus delta x minus f of x divided by delta x. I'm gonna plug in. That's mean f prime to the x is going to be the limit when delta x approach to the 0, f to the x plus delta x here, square root of x plus delta x minus 1 minus f of x, which is square root of x minus 1, everything divided by delta x. And that's the important step. How are we going to simplify this one? I have square root. So how am I going to simplify this one? We're going to multiply everything by the opposite sign, which is the conjugate for this numerator. So we're going to rationalize the top part here. So we're going to multiply by square root of x plus delta x minus 1 plus square root of x minus 1, which is the opposite sign between these two terms. So we can rationalize. Over, again, we have to multiply the bottom part 2 plus square root of x minus 1. Now let's keep going. This one times this one. I need you to check. Square root times square root going to be equal the limit when delta x approach to the 0. It's going to be x plus delta x minus 1. You have to FOIL these. Imagine these two parentheses. Okay, and FOIL it. So the result is going to be for the first part. I'm just going to write down. I'm going to skip a step. So you have to figure out how we're going to get this one. Minus is going to be this one times this one. Minus parentheses, x minus 1. Over, here is delta x, square root x plus delta x minus 1. times another square root, which is x minus 1. Next step, we have to simplify. Distribute the negative sign. Distribute the negative sign here. So it's going to be equal the limit when delta x approach to the 0, x plus delta x minus 1 minus x plus 1 divided by delta x square root of x plus delta x minus 1 times x minus 1. There is a sign here. I forgot the sign because there's a plus. It's not multiplication. The bottom part is going to be plus square root of x minus 1. And the same thing here. Plus square root of x minus 1. The bottom part here, when we rationalize, there's a plus. So cancel this one with this one, -1 with 1. The left is only delta x. Cancel delta x with delta x. So on the top part, the result is going to be the limit when delta x approach to 0, 1 over delta x. We just have x plus delta x minus 1 plus square root of x minus 1. Now, when the limit goes to the 0, that means this term is going to be 0. So we have x minus 1 and x minus 1. In this case, this one is going to be equal 1 over 2 square root of x minus 1. Because we add square root with the square root, so it's going to be 2 square roots of x minus 1. So this is the slope. Now we need to find the slope at this point, at the point 10, 3. At this point, this is the slope for the tangent line. But at this point, our slope is going to be equal 1 over 2 square root. I'm going to plug in the 10. 10 minus 1. So it's going to be 1 over 2 square root of 9. So it's going to be 1 over 2 times 3. Square root of 9 is 3. So it's going to be 1 over 6. So at this point, this is the slope of the tangent line for the whole line. But at this point, our slope is 1 over 6. So now next step, I need to find the equations of the line. I have point, there is xy, x1, y1, so it's going to be y minus y1 equal the slope, x minus x1. That's mean y minus y1, which is a 3. Our slope is 1 over 6, x minus x1, which is 10. Next step, you just have to simplify it. Or you're going to keep it like this, it's going to be fine. Move the 3 to the other side, so y equal 1 over 6, x minus 10 plus a 3. You can keep going and simplify it more by distributing 1 over 6 and combine these two terms. So this is the equations of the tangent line at the point 10, 3.